Hello. Graphing equations. So this is pretty important. A graph is just a visual aid that humans use to understand mathematical relationships, basically. Here's a more precise definition. The graph of an equation, in two variables at least, is the set of all points whose coordinates x, y satisfy the equation. So when we talk about a set of all points, well, when we draw a bunch of points on a coordinate system and then connect them all with some sort of line or a curve, that's what generates what we kind of know and think about as a mathematical graph. Magic shirt change. So let's start with an equation that we've seen before. In the last lecture, we saw this equation, y equals 2x minus 3, and we just plugged in some values for x, no special values, we just picked some, and we got a bunch of values for y. So let's see what all those points look like when we put them on a coordinate system. That's what they look like. And it doesn't take a genius to tell that they look like a line. So if we were to draw a line, a curve through all those points, that curve would be a straight line. And we would trust that all the other points that live on that line would also be solutions to the equation. Like that. So that basically goes for how you can graph any curve by hand. You just pick some points and notice the shape and then draw the shape. Okay, so this is called a linear equation. Anything of the form that can be written in the form ax plus by equals c is linear. And you'll see that, so the way we have it now, y equals 2x minus 3 isn't quite that. But it can be that. It can be written that way. So it's linear if there's just no x squareds or x cubed or square roots or any other fancy math stuff you might know about. If it's just x and y to no powers with some constants floating around in there too, the graph of that equation is going to be a line. And now we'll just dig in and explore graphs of lines. So if I just give you 2 points floating around in space, you can draw the line through them. And a linear graph is really the only graph that's like that. So that really, if you know that the graph is linear, that's the fastest way to do it, is just to pick 2 points. So the easiest points to find are called the intercepts, and that's important going forward. So where the line hits the x-axis and where the line hits the y-axis are called the intercepts. They're called the x-intercept and the y-intercept. Like those red things. So notice on this point, that hits the x-axis. And the y-coordinate of this point is 0. At this point, that hits the y-axis, and the x-coordinate of that point is 0. These are nice to use because 0 is a very easy number to plug in. It's very easy to plug 0 into an equation because one of the variables will just vanish. Okay, so for right now, for our purposes, that's why it's important and nice to graph using the intercepts. Okay, and here's what we are. Now, I haven't told you how I got those, but just look at the graph and believe me. So the x-intercept where it hits the x-axis is 3/2 comma 0, and the y-intercept where it hits the y-axis has coordinates 0 comma 3. So right at the y-intercept, the x-coordinate is 0, and at the x-intercept, the y-coordinate is 0. So here's how you do it. So to find either of the intercepts, you just make the other variable 0. Like that. And you can probably almost do that in your head. When you set x equal to 0, well, the 2x just goes away, and you have negative 3y equals 6, which means that y is 6 over negative 3, which is negative 2. Like that. Okay, so that's a point. So when x is 0, y is negative 2. There it is. And then just do the exact same thing for the x-intercept. For the x-intercept, you want y to be 0. So it's going to be 2x minus 0 equals 6. Right, that term just vanishes, so it's just 2x equals 6. and x equals 3. See how easy that was? So this isn't the only way to graph a line, but it's the quickest way. Right, because now all you need to determine a line is those 2 points. So just draw a line connecting those 2 points and you have it. See? Beautiful. Let's play around with a couple special cases. So this looks a little different. It's like ax plus by equals c, except there's no y. So it's like the y coefficient is 0 or something. So let's just think about what that looks like. X equals 3 no matter what y is. So remember the x-axis is the horizontal one, which means x is 3 and y can be anything at once. So that should look like a vertical line, right? Because it's independent of y. So it is. So that's how you have an equation for a vertical line. Samesies if you just had y equals 2 or 5 or -5 or whatever. 2 is not special, but we're just saying that y is 2 independently of what x is. So that means for y to be 2 no matter what, you just have a horizontal line. Like that. So when you see linear equations that are simple like that, know that they're one of the two. And coming soon, it's going to be important to distinguish between the two. Okay, thank you.